Hi, good morning. I'm going to do a little sound check in a minute and just make sure that everything's coming through okay in terms of the volume. So today is the 12th of November, and I apologize because I know that several of you joined from um, Southeast Asia, and we've actually had a bit of a time zone change. So London now has London has had a time zone change, and so what was 2 p.m. for you has now become 3 p.m. Or rather, yeah, rather it's now 3 p.m. in the afternoon for you guys. So my apologies for that. So I'm just going to say hi to Hasim. Just Hasim is here. So yeah, so I think everyone's coming here. My apologies that we got the time zone a little mixed up this morning. Like I say, London changed its clocks a few weeks ago, and we forgot we forgot to synchronize ourselves with you guys. So apologies for that. So this is the ZP Developer Zone webinar. We do it every week. We really try to encourage a collaborative, experience between us all. I think we do have a really good collaboration going with Abril, and I want to just expand upon that theme of collaboration this morning. Hey, there's Dima. Hi, Dima. Yeah, so I want to expand upon that theme of collaboration this morning. So let me just play you some slides and see what you guys basically think. So, I mean, at Zero Peacock, we imagine that that you guys are out there, and potentially we could collaborate together and we could do some good stuff. Now, obviously, we're very keen, at Zimmer and Peacock, as we very keen on electrochemistry. So we have these little potentiostats, and for example, we have these screen printed electrodes. So I know that Hasim Hasim has some of these electrodes at his place. And if you're interested in them, maybe talk to Hasim. But in the end, we've got this idea that you'll be able to get some potentiostats, get some screen printed electrodes from us, and then we have to think, or not then, we have to think about the application. What is it we want to measure? So, I mean, I put some pictures down of some spices there because obviously, one of the big industries around the world is food and agriculture. So it's not a bad thing to think about making. There's ISO as well, right? So it's not a bad thing to think about. There you are. We have screen printed electrodes. We have potentiostats. Let's think about what we can actually analyze. So for example, spices, aflatoxins, whatever it's going to be. Now, the next stage in that collaboration is to get some electrochemical data. So I think some of the guys who really understand how to get electrochemical data, for example, I'm pretty good at it. Many of the guys at Zimmer and Peacock are good at it. Hasim is good at it. So we need you. You need to have one of these potentiostats. You need to have screen printed electrodes. You need to have samples. And I think an example of that is Abril. Abril has some very interesting types of samples. And then we need to get some electrochemical data. Now, what we also would be interesting is if you could get. So let's say you were testing for aflatoxin. If you make up a solution of aflatoxin, then you will know the concentration of aflatoxin in that sample. So you'll know it because you actually put it into solution. And you could also know it because you've got another test for it. And it's very important to you because what I'm trying to encourage is the idea that you will gather electrochemical data and you will gather, you will absolutely know what the concentration of the analyte of interest is because you either put it into solution or because you tested it by another means. So, what I'm looking for you guys to do potentially is actually to collect electrochemical data and to give us, we call it the metadata, but the metadata would be a sample description, the known concentration. So it's not just here's the electrochemical data, it's also a description of the concentration is useful, what the sample type was, all the details that kind of allow us to understand that data. Because then what we could do you could upload it to a database called Julie. So Julie, I will discuss it. I'll give you a demonstration in a minute of Julie. But the idea is this, that in some ways, you've got the energy, you've potentially got the samples, you've hopefully got some electrodes or some biosensors, and you've hopefully got a potentiostat. So as long as you've got yourself, the potentiostat, the screen printed electrodes, and the samples, then you can generate some electrochemical data. But then the next challenge is how to convert that electrochemical data into something that is useful. So what I would, so let me just go a little bit further ahead with this now then. So what I'm suggesting is this, that you have basically your toolbox, your samples, your screen printed electrodes, your potentiostat. You're able to gather your electrochemical data. And then I'm suggesting you actually upload it to Julie, which is a database that we run, where basically what we can do is this. You'll upload your electrochemical data and your notes. And then what we're going to do is this. We're going to extract the electrochemical signal from it. And when I say that, traditionally, if we were doing cyclovoltammetry, for example, people would look at the peak height of the signal and say, that peak height is proportional to concentration, and therefore they would just plot concentration versus peak height. But we live in a very different age these days, where data science there's many more data scientists around, and people are getting better at looking at data. So Zimmer people, we have a different philosophy, which is we don't just look at simple things like the peak height and say, that peak height is proportional to concentration. We might look at the peak area. We might look at the peak height, peak area, and the peak position as all being indicative of the molecule of interest, all being indicative of the concentration. So I'm saying that we can get the electrochemical signal from your data in many more sophisticated ways than were traditionally taught at university. But the first step on that process is actually you getting the data, because the effort in the lab it takes to get good data is actually quite considerable. And that's kind of where I see the collaborations really coming into play, that you guys can get that kind of quality of data, upload it, then we can step in then with our data analysis and extract the electrochemical signal. Because if we can get the electrochemical signal out, we have a data scientist group that can effectively do that. And we know the concentration. And the reason we know the concentration is because you told it to us in the notes. I call it the metadata, but it's really in the notes that you said, known concentration, either because you knew it because you weighed it out, or you knew it because you actually also measured it, which is even better. Sometimes for maybe something like aflatoxin, there's a golden standard or golden way of measuring that aflatoxin concentration. And if there is, then it's good to take your sample and measure it both electrochemically, because that's the electrochemical sensor that you're trying to make, but also test it by the traditional method. Because what we want to do is we want to get the electrochemical signal, which is proportional concentration, and we want to know the true concentration as either because you measured out the analyte or because you measured it by a known, recognized methodology. Because we want to do is we want to plot these two things on an axis together. And so you'll give us several sets of data, and we'll plot the electrochemical signal versus known concentration. Again, we'll plot the electrochemical signal versus known concentration. Again, electrochemical signal versus known concentration. Again, electrochemical signal versus known concentration. Now, that does seem, so straightforward, because that's effectively what we do. That's what a lot of experiments are like, signal versus concentration. The only difference is we're not just looking at the data in a simple way. We're not just looking at peak height, as I say, or peak area or peak position. As different people will actually look at the data much more holistically, because there's when you have a full spectrum of electrochemical data, there's sometimes subtleties or relationships within that data that when you combine them, the overall signal is more strong. Or when you combine them, or when you do a difference measurement, the overall signal is much stronger. So it's really this step where ZP can help add a lot of value, which is the extraction of the electrochemical signal. If you was just going to be peak height versus signal, then you can almost just do it yourselves. But there's a step here where we could really extract the most information from the data, and ZP would be pretty good at that. So anyway, what we're saying is let's you gather the data, you upload it, we'll try and extract the signal from it, and then we're going to plot it against the known concentrations that you told us about. So if you knew it was 1 millimolar, that would be 1 millimolar, and then we would measure the electrochemical signal, maybe 1 microamp, then 2 millimolar and 2 microamps, maybe 3 millimolar, and that was 2.5 microamps, maybe 4 millimolar, and that was 4 microamps. We'll do that kind of correlation. Do the plot, which is fairly straightforward, as you know, and then come up with the equation that says that concentration is obviously equal to maybe the signal minus the intercept divided by the gradient. So we're just kind of what we're doing is just figuring out the relationship between signal and known concentration. And the reason I say all of that is if we can do all of that, then it's easier for us to then just take that formulation and put it onto the FoodSense app. And we're sort of on a good road then to actually getting something to the market, or getting something getting something that really works. So if I was to summarize what I've said so far this morning, is I've said that ZP and the ZP Developer Zone is all about collaboration. And I think we've demonstrated that through at least one of our members is starting to be able to give public talks about this kind of work. The next stage in the collaboration in some ways is we need to start getting some of these units into your hands along with the screen printed electrodes. And you need to start working on the samples that you're interested in measuring. Because then if you've got that data, we can give you an account into Julia, and you can upload your data and we can start analyzing your data. So let me change gears slightly now and show you what Julia is. So I'll just pull this onto my screen. So Julia is a online database and it is a data storage and data analytics. Yeah, that's right. Yeah, Hasim is correct. The point about the work, Hasim has just asked a question, and the point about doing the workflow that I've just described is, we can eventually get this stuff onto Android type apps. Otherwise, it just remains as scientific papers, and it doesn't really take the next steps. So now I'm going to describe what Julia is. I'm going to just give you a first sort of demonstration to the developers on what Julia is. So this is Julia, which is a data storage and data analytics system that we have at ZP specifically for electrochemical data. So I'm going to go into some data now and show you this. So at ZP, I talk to you an awful lot sometimes about potentiometry and voltammetry, and I sometimes mention amperometry. So what we have here is amperometric data that's been gathered in our lab. And so we have all this data, and the data changes. And what happens is we do an experiment and we gather a baseline. And then at this point, we add in a known concentration of material and the signal changes. So I understand this experiment, that there's effectively a 0 concentration of material. And then at about 1500 seconds, the scientist adds in a known concentration of material. So that's literally, so literally the current changed as we added in the material. So what I'm going to do now is I'm just going to go into what's called edit mode. You can't see it. And what I'm going to do is I'm going to hide my camera for a second. I hid my camera so that you actually could see the screen better. So I've gone into what's called edit mode. So this is into edit mode. And under tools, you can see that we can upload data. So if I go to tools, we can actually add data. So this means that you can have an account with us. You can add the plus sign, and you can actually add data. So when you add data, then you will upload your data, and it will look, for example, like this. Now, this is cool in some ways because what it means is now here we've uploaded 7 data sets. They're all plotted together. And now what it means is we can actually do the analysis, for example. Yeah, Hasim is asking, next question is how do we input data to Julia? And as I say, Hasim, I might have to drag my screen slightly because I realize it might be covered up. So I'm going to drag my screen just very subtly and realize it's these tool buttons here, Hasim. There's a tools button, and we can add data through this button here. So my apologies, because I realize it's kind of slightly hidden underneath my camera, and I apologize for that. So you can upload data to Julia. You need an account. So you do need an account to do that. But once you've got it, you can upload data to Julia. Now, I would say Hasim in particular, because he works in a kind of how would I call it? Yeah, a real not real, but it's an analytical laboratory. So they're very keen on quantification, like limit of detection, limit of blank, limit of quantification. And what Julia does is it allows you to take all your data and actually kind of get those metrics very quickly. So let me just show you a slightly different feature on Julia, which says this, that what Julia is able to do, for example, is it's got all this data in it, and it's asking the question, what was the concentration at this time point here, and what was the concentration at this time point here? And what it does is it will then use all of the data to figure out basically the straight line for that data. So let me just show you. What I'll do is I'm just going to move this around a bit. So if I say, look, at 1100 seconds, the concentration was 0, and at 1750 seconds, the concentration was 10. What it's doing is it's looking at what it's now doing. It says, right, at 1100 seconds, the concentration is 0. At 1550 seconds, all of these signals that for different electrodes or different sensors are all at 10. And using that data, it's therefore calculated. It's not very good because you can see there's these sensors are quite variable. But it's actually said that the limit of detection was 4.42. Now, if I just fool the sensor a little, I'm just going to pretend now that, in fact, that concentration wasn't 10, but it was actually 5, for example. Now, obviously, my limit of detection is kind of halved. It's gone down to 2.22. So I'm just showing you what Julia allows us to do is that it allows us to do analytics online, and it allows us to do a lot of batch analytics. So rather than trying to extract all your data manually and do all this manual investigation of your data. We can do it fairly automatically. And one of our guys described it as giving you a 360-degree view on your data. Because when you look at it, for each sensor, we said there were 7 sensors overall. It tells us the intercept, it tells us the gradient. So I can see all the different intercepts, I can see all the different gradients, I can get an overall, or maybe we should call it average intercept and gradient. It tells me what my standard deviation is for 0, and what my relative standard deviation is. And it tells me what my standard deviation is for 5, and what my mean is, and tells me that my relative standard deviation is 30%, which makes sense because when you look at the raw data, you can see the spread in the data here. So it's not surprising that it's, it's quite, let's say, high. So I do like Hasim's comment there about, wow, it's amazing. Yeah. So that, we have this Julia. We can make accounts for people, but there's no point in having an account unless you've got, all the other parts of this, and the other parts, really go back to my my original presentation, and I'll only do it very quickly. We need you to have these, potential stats and screened electrodes. And we need you to have samples, and we need you to measure those samples, and we need you to give us the meta information, or tell us what the concentration is, or measure the concentration. Both is best. And then we need you to upload it to Julia. And once we get to that stage, we're sort of on our way then to doing a really good job at analyzing your data, pulling out the electrochemical signal. We know the concentration because you told it to us. We can do the correlation. We can figure out the equation. And as Hasim says, once we're there, then we're much closer then to actually being able to make, Android type apps, which is a really good point, because I think actually, I think Hasim and Jati in Indonesia are very interested in the app development. And so this kind of workflow will really get towards that. Yeah. And Hasim's making some very interesting comments online here. He says, well, it's nice, first of all, he says, wow, it's amazing, which is great. Can we make a biological applications such as qualitative? And absolutely, we should. If you've got an assay that can be more qualitative than quantitative, then, obviously I mean by that, is it yes or no? Is the pathogen present, yes or no? Rather than yes, and there's this much. Then that is, it's easier to do qualitative rather than quantitative sometimes. That's one of the questions. Yeah, and he also makes a really good point, actually, and I didn't say this, negative and positive results. Yeah, we definitely need negative results. It's a really good point, Hasim, and I should have made it, because especially when we've been talking about machine learning a lot, that in machine learning, you need to give machine learning, known positives and known negatives, so that you can teach the machine, and then you can give it unknown results. And if it gets it incorrect, we can train it better. So yes, known positives, known negatives. Can we start from our members if they have the data? Yeah, this is literally what I'm about, Hasim. The members need to start generating this data, because if they're generating the data, then we can start doing the data analysis. So we have a collaboration going with Abril at the moment. The question is, who's going to be the next guy to start, sort of generating data so that we can start this collaboration. What I'll do is I'll just turn my camera back on. I turned it off so that I thought I was going to stop covering up the screen, but I realized it didn't do that. So we're coming up to 1:30. We always try to keep these things, we try to keep within time. So I just wanted to kind of tell you about Julia. I wanted to tell you about, obviously, our passion for collaboration. I do appreciate you guys all coming along, because, it was an hour later than you were expecting, and our apologies for that. So yeah, London has changed it changes its time zone when going from summer to winter, and that did throw us off a little bit. So we made sure we get that right next week. Yeah, so Issa is just asking, so there's a supporting staff or system inside Julia for discussing whether there are strange signaling experiments. Yeah, I mean, the idea is, Issa, that if you're putting data up there, we can both use the machine learning to analyze your data, but also it's a very good way of your data getting to us, and we can look at it like experts, with you. So it's just a good way of storing the data, and us analyzing the data and you being able to analyze the data. So it's much more collaborative. So that's why we're kind of calling it real-time collaboration. All right. Some of the guys are suggesting that we get online and have a chat about this. So I agree. And yeah. It seems just asking why we call it Julia. So yeah, one of the development engineers, his wife is called Julia. This is the Norwegian spelling for Julia. So yeah, the D in front of it is because, as you know, the company has a strong presence in Norway, and one of the guys' wives is called Julia. So we named it after her. All right, I'm going to wrap up now. Yeah, see you next meeting, Hasim, and see you next meeting, guys. I appreciate it very much. Take care.